Welcome to myiacademy.com. I'm Professor Mahfooz from Jinnah Medical College, Pakistan. In this video, VHB 16.2, we are going to discuss OCT or Optical Coherence Tomography, which is one of the ophthalmic investigations. This one is B-scan or sonography. This is OCT. This one is FFA or fundus fluorescein angiography. Number 4 is the visual field. Number 5 is the corneal topography. And number 6 is the A-scan. And here we are going to only talk about the OCT or optical coherence tomography. Let's first watch out how the OCT is done. Look at that. This is the OCT. And here we can see the OCT picture, and here is the printout. Here you can see histological sections of the retina. Number 1 to 8 are the retinal layers, and number 9 is the choroid. So this is number 9 and this is choroid, and this number 8 is retinal pigment epithelium, and number 7 is the outer processes of rods and cones. All these layers you can see in the OCT. So the outermost is the retinal pigment epithelium, and third from the out is the inner segment, outer segments. Let's magnify it. Look at this OCT. You can see all the 10 corneal layers. All you have to concentrate on these white lines, these 3 white lines. All you have to remember is the outer one is retinal pigment epithelium. So this white line is retinal pigment epithelium. This one, the first one, is the retinal pigment epithelium, and the third one, this one, is the ellipsoid layer or junction of inner segment and outer segments of rods and cones. So all you have to remember is the first outer layer is retinal pigment epithelium, and the third from outside is ellipsoid or isos layer. So ocular coherence tomography means cut. So you have seen the cut of the retina or the section of the retina, and you can see the layers one by one. The source is the light. The purpose is for analyzing the layers of the retina. Now remember, not for visualizing but for analyzing. The uses are integrity or damage to the particular layer. So if you want to see a damage to a particular layer or a pathology in a particular layer, you can concentrate on that. Presence of edema or exudates in the layer, the presence of defects or the holes in the retina, and you can also see the choroid. Let's see some examples. In the first example, you can see these corrugations. These are the drusens which have elevated the outermost layer of the retinal pigment epithelium. In the next one, these are the inner layers, and you can see a small black cystic spaces which is water or edema. So this is macular edema. In the third one, you can see that the outer layers are atrophic, which is seen in age-related macular degeneration. And finally, in this one, you can see a hole in the inner retinal layers, and we call it a macular hole. And at the end, let's discuss the difference between B-scan and OCT. In the B-scan, there are ultrasound waves, while in the OCT, they are light waves. In the B-scan, a transducer or a black handle detects the lesion, while in the OCT, a spectrometer, which is a specialized device that detects the lesion. B-scan has got a 2D image, OCT has got a 2D and also a 3D image. The main difference is the B-scan has a resolution of 150 micron, while the OCT has a very good resolution and can detect lesion up to 5 micron. Another very important difference is low producibility. You cannot produce the same picture again and again, where in an OCT you can reproduce the same picture at exactly the same spot again and again. So it's very good for the follow-up. You can see a lesion growing or shrinking over the time. And the main difference is B scan is possible with the media opacity, while the OCT is not possible with the media opacity. You need a clear media. So that is the difference between the B scan and the OCT. And thanks for being with me. Please do give your feedback. Thank you.